Diffusion of gases. We are looking at how mass affects the rate of diffusion. To do this lab, it's very important that we pay attention to the fact that gloves will be needed, goggles, and of course respiratory mask, as we are going to be working with chemicals that are both corrosive and pungent. We want to determine how mass affects the rate of diffusion. We're going to be working with ammonia, and we have to be very, very careful because using ammonia, you might go unconscious with sniffing the ammonia. We're also going to be working with hydrochloric acid solution. If you observe here, just to demonstrate, the containers are supposed to be kept closed. Failure to close these containers will cause a reaction in the lab that will cause a smoke-like cloud where students might go running all about. So we really don't want that to happen. So ensure that both containers are kept closed and kept apart from each other. We're going to need retard stand to hold, of course, the setup. So there we have a cotton swab in a glass tube. To the left, we have ammonia in a tree, which was, of course, immersed in ammonia solution. And to the right, we have hydrochloric acid, which is providing the hydrogen chloride gas for the reaction here. Now, it's very important that we pay attention here as we want to determine which of these gas would be denser. So we want to look at how fast the gas will move. The indication of movement for this experiment will be demonstrated by a white ring, which will be formed in the tube as soon as the gases meet. So let's go right into the experiment. You want to grab your stopwatch as soon as you see that yellow band at the top of the screen start going sideways. It indicates that the experiment would have started. So it is an animation, so a lot of things we would have slowed down here. So we're about to start the experiment. Let's go. So there we have it. The gases are now moving in the tube. You're seeing a formation there of the white ring. It's been formed somewhere right here if you're looking at the cursor. A ring being formed here, which is suggesting that the ammonia is the lighter gas as it tends to travel faster and pretty much farther than the hydrogen chloride gas. So you're seeing the ring here being formed closer to the hydrogen chloride than it is to the ammonia. So the experiment is now finished. The ring here has been completely formed. But if we allow this to go on, what would happen is that we'd have a further ring of cloud being formed, moving towards the direction of the hydrogen chloride gas or the hydrogen chloride cotton swab. Now, the ring there being formed, it is a solid ammonium chloride, NH4Cl. So that white ring there is pretty much solid and we're working with gas. So the gases react to form a solid ring of ammonium chloride. We're seeing a movement here for hydrogen chloride. The arrows are indicated. If you look at the arrow, you'll realize here that indeed ammonia had covered a greater distance than hydrogen chloride gas. There we have the separation. Now there are some factors which will affect the rate of diffusion. So while this experiment would have taken a particular time, it could have been speed up or slowed down based on any of the factors we're going to be looking at. Mass will definitely affect the rate of diffusion, as is demonstrated here in the setup. Particle size will also influence the rate of diffusion. It could cause diffusion to go fast or slow depending on the size of the particles. Concentration, the concentration of that which is being diffused, will always affect the rate, the speed at which, of course, the particles are diffused. Then, of course, we have temperature, which will impact the rate of diffusion. could cause particles to travel very far and very quickly, or pretty much to stay pretty much within a confined area, depending on the temperature. Now, while diffusion seems to be a laboratory activity, diffusion is always taking place around us. There's diffusion in plants with the oxygen and the carbon dioxide, pretty much oxygen diffusing out through the stomata of a leaf and carbon dioxide diffusing in. And also in animals, we would also have diffusion where we have things moving across the membrane because of concentration gradient. So particles would be moving across the membrane. To find out more about examples of diffusion in plants and animals, you want to check out my video on diffusion. Thank you very much for watching. Please be reminded to like, share, and of course, subscribe. You can find us online at tcp-academy.teachable.com. You can also find us at YouTube at CSEC Biology TCP. Please be reminded to join us in our live classes on YouTube. You may also sign up at TCP if you need help with biology or human and social biology. Last year, many students differed on their CXC exams as they were afraid of failure due to their level of readiness. This year, Mr. Wilson and his experienced team from tcpacademy.teachable.com is here to help you get exam ready. Subscribe for free to tcp-academy.teachable.com. We offer courses in CXC Biology, HSB, English Language, and many others. There are several offerings to each course. Enroll in one today.